My topic is all you need to know about dedicated SQL pools. I have included most of the stuff. Let's see what we can get through in the next 15 minutes, 10 to 15 minutes. My name is Indira Bandari and I'm a Microsoft Data Platform MVP. And a little bit about me, I have a master's degree in statistics and have been in the data space for over 20 years. And I have a passion to teach kids all about technology. And during COVID time, I started a trust called Kids Tech Charitable Trust to teach kids all about technology. I teach SQL and Power BI. So moving on. So today's agenda is I'll just very briefly go through the Azure Synapse dedicated SQL architecture, and then I'll cover the control nodes, compute nodes, data movement service, Azure storage, and also some best practices or some sort of a cheat sheet. So a little bit about Azure Synapse architecture before we go to the dedicated pools. It is analysis. Synapse Analytics is a analytics service that brings together enterprise data, warehousing, and big data. So that is where the dedicated SQL pools come in. And in the dedicated SQL pools refers to the enterprise architect data warehousing features that are available in the Azure Synapse Analytics. Now, this slide shows the architecture components of Azure Synapse SQL. So you can use the Synapse Studio in the Synapse workspace, and you have the connected services, common security model, shared meta system, and pipelines. And we have these pools, dedicated SQL pools, serverless SQL pools, and Apache Spark pools. We are going to just deep dive into the dedicated SQL pools. So here is a little bit of the architecture of dedicated SQL pools. Here it's a collection of you can see the control nodes, compute nodes. DMS is the data movement service, and Azure storage. What you can see is the compute and the Azure and the storage part are both decoupled in this, and it mainly follows the it's a massively parallel processing engine. So if we deep dive into the control node, the control node has a distributed query engine which runs on the control node, and it has optimized and what the control node does is it optimizes and coordinates the parallel queries and sends into then passes on the compute to the to run parallel processing. So this control node then hands over to the compute node. In the compute node, the distributions map to compute node for processing, and they provide computational power. Computational power. So when we add more compute nodes, then more resources will result in remapping the distributions to the next available compute nodes. And also these compute nodes, after computing, they all store all user data in Azure storage. If we go to the before we go to the Azure storage, we will understand what data movement service is. Data movement service is the data transport technology that coordinates data movement between the compute nodes and the between the various compute nodes. So some queries require data movement to ensure the parallel queries return accurate results. So that is the reason this data movement service is needed. And when data movement is required, the DMS is usually called DMS, data movement service, ensures that the right data gets into the right location. So that is the role of data movement service. And to cover a little bit about data movement service, the distributions happen in three types. Those are called the hash distributions, round robin distributions, and um, hash distribution and round robin distribution and replicated tables. So these are all the tables, different kinds of tables that can be used. When we go to the Azure storage, so Azure storage if we use Azure storage, the user's data is safe, and there is separate charge for storage consumption, of course, and then the data is sharded into distributions to um, optimize the performance. So when you choose the sharding pattern, that's when you define these tables, the different tables that I mentioned. That is the hash table, round robin table, and replicate table. Now, the features of the dedicated pools are you can grow or shrink compute power separately to the storage within a dedicated SQL pool without moving data, and also pause compute capacity while leaving the data intact. So when you are pausing capacity, you only pay for the data storage, and resume the compute capacity during just the operational hours. So that way you can save the cost. Now, if we look at the next one is the sorry, next one is the dedicated SQL pool best practices. So here I have given a sort of a diagram. So here you should need to look at what queries and operations um, can be passed across the table. Uh, so so for example, when joining one or two fact tables with dimensions, filtering the combined table and then appending the results into a data mart, or making large or small updates to your fact tables, and also appending only data into your tables. So when you are migrating data, first load your data into the Azure Data Lake Storage or Azure Blob Storage, and then you can use the copy statement to load your data into the staging tables. And distributed or replicated tables, as I mentioned, you can use the for small dimension tables into a star schema with less than maybe 2 GB storage. This is a great fit for that kind of scenario, the replicated tables. And round robin that I mentioned, the round robin tables, they are mainly temporary or staging tables, and no obvious joining key will be there is a good candidate. So when there are tables with that kind of feature, then round robin tables are suited. And hash tables are mainly suited for fact tables or large dimension. If you have large dimension tables, then also you can use hash tables. And next one is indexing. Indexing is helpful for reading tables quickly. If many of you have worked with SQL, then you would know. And there is a unique set of technologies that you can use based on your needs. So there are heap type of index, and clustered index, and clustered column store index. Column store is used for very large tables that are that have more than 100 million rows, and tables with up to million rows, you can use clustered tables. And for a heap, it's a temporary or storage staging tables that you can use. Next comes partition. Partitioning is you might partition your table when you have a very large fact table. So let's say greater than 1 billion rows, and usually the partition is done based on the year, or based on month, year, or something like that. And with staging tables that require ETL, then you can benefit from partitioning them as well. Next comes the incremental load. So if you are going to incrementally load your data, first make sure that you allocate larger resource classes to your to loading your data. Now, this is particularly important when loading into tables with clustered column storage indexes. So that's when I think it's better to use Polybase or ADF version 2 for automating your ELT pipelines into your data warehouse. Um, and then the main thing is prioritize your first queries and prioritize first your queries and transformations into dedication SQL pool, and then next your incremental loads. So that is what I think I have planned to say. And the way to get started is to quit thinking and begin doing. I like this quote about from Walt Disney. And that's it. That's me. Thank you.